So again, this is lesson 1 of the study group that we form around machine learning course from Fast.ai, together with the This Week in Machine Learning podcast. So let's start. So I've put a short presentation together with some other folks that are also organizing this together, just to start the discussion, and then let's see how we want to get the discussion going. So a little bit of agenda. We'll go through some intro about our study group, the information about the course. We're going to talk a little bit about how to run notebooks for those that didn't manage to run them yet, about some key concepts that were discussed during the lesson 1 video, and then we're going to open for a discussion basically about the course, about anything that's related to a course in lesson 1, especially this time. And then next step, and then also some links with the resources. Let me see. I'm just going to also from time to time check on the chat just to make sure I don't miss anything. I can see there is something. Right. So there's a question about the agenda. It's indeed, yes. So I'm going to make that available after the meetup. I guess that's going to be easiest, unless I can just copy and paste that link now. Let me try to do that now. Okay. Right, so you should be able to get that link. I hope that works. If not, I'm going to paste that as well after the meetup. Right. Okay. I'm going to go to the next page. Right, so there are a couple of us that organize that study group. So we have Sam. Sam is the from podcast. So he's providing us with all the resources and the Zoom stuff and advertising our group. So thanks for that. Then we have Christian. So also you can find us on Slack. We have Dinesh, we have Sanyam and me. So if you have any questions about the course, please reach to us on Slack. So about the group. So the goal of the group is to provide support and encouragement. So we're not teaching as per se in that class, in that group. We watch lessons before the meetup, and then we try to do homework as much as we can before the meetup. And then in the meetup, we discuss about the lesson, what was interesting, what was difficult, what was fun, there are channels that we discuss. So if you're not on Slack channel, please join, and then join the Fast.ai channel. That's where you can meet most of us. And then we have weekly Zoom sessions. So this is the place for us to discuss real time, talk about the lessons. The information about the course. So this is the machine learning course, which is new course from Fast.ai. Although it just recently launched officially, it was available already for a while on a forums of Fast.ai. So some guys maybe already did some lessons, but it is officially launched just like last week. And it covers the machine learning part as opposed to the previous course that they did, which was on deep learning. So this one talks more about the tabular data, like structured data. And it's the first part of the course is mostly the decision trees models. And then the second part is more based on the gradient descent based models like neural networks and logistic regression and so on. And also Jeremy Howard, the person that created the course together with his team, he's got a lot of experience in machine learning and deep learning, and it's great to just hear his ideas about how to approach the data and how to perform analysis. So he recommends to spend about 8 hours per week, per each lesson for the 12 weeks. But that, of course, depends on how much time you guys have to put in that course. And you get as much as you put into that. So it's actually depends on individual. You can just watch the lesson, or you can do more. He actually recommends doing a lot of on Kaggle, like competitions, and that's great way to learn as well. So please also let me know if you get any questions. So I'll do it fast through that just to make sure we have enough time to discuss the lesson one, but please let me know if you have any questions. Let me check chat screen. How do I do it? Questions, chat. Right, I don't see chat anymore.
What's the recommended environment, Mikhail, for this one? Is it Crackle kernels also, or something else?
Yeah, that's a very good question, and I try to cover that in this slide. So just bear with me 1 second. I will go to there. So a bit of a lessons overview. So we have 12 lessons. We're going to go with pace 1 lesson per week, and I think that's realistic. The other group, deep learning, they were kind of halfway through the course. They've changed to 1 lesson per 2 weeks. I think the machine learning course is a little bit more kind of go on slower pace, and the lessons are, the videos as well, a little bit shorter. So we'll at least try to start with that, and then we can decide if that's appropriate. So we have the first 6 lessons are actually 7 lessons are about random forests. I have something in the chat. Let me check on that. Right. So there's a question about the certificate. So that's right. So the certificates are only for people that attend the in-person course at the University of, I forgot, San Francisco or something, Data Science Institute, something like that. And that's in San Francisco. So for that, they do offer certificates, but for the online, not necessarily, no. So it's basically, they offer this for free. Anyone can join, watch, but there are no certificates for the online. Right, yeah. Thanks, Christian. That's right. So then, so I was talking about the lessons. So then we have lesson from 8 till 12. Then they switch to gradient descent based and logistic regression based models. They talk about natural language processing, talk about the columnar data as well for neural networks, which is quite a cool concept. They talk about embeddings and the Rossmann competition from Kaggle, that it's on tabular data, the structured data. And also the lesson 12, it's also a very important topic about the ethical issues with the AI and machine learning. I think that's also important.
Michael, I wonder if you could, and maybe you're going to cover this shortly, but basically the difference between machine learning and the deep learning. And I understand deep learning is a subset of machine learning, but it's still not clear what's within which basket.
Yeah, that's right. So the machine learning, indeed, the deep learning indeed is a subset of machine learning, and Jeremy also kind of, maybe not lesson 1, but also that discussion is many times on the forum. It's quite confusing, and also was to me. I'm still like trying to understand this also better. So the way I understand this is machine learning is those techniques and algorithms and tools that mostly deal with the structured data, the tabular data, and then the deep learning is a subset of the machine learning algorithms, which is specially designed to work with like unstructured data, so like images or natural language processing or audio or video. So this type of algorithms, and mostly we have the neural networks. Either this is like convolution neural networks. So this is what we call the deep learning, where you have the deep comes from your layers that your neural networks got. So you have the input layer and the output layer, and all the layers in between are hidden as such. They called hidden. and the more you, and also deep layer, they call also deep layers. So the deep learning comes from that, is just the class of models that are used for those type of problems. But please, anyone who's got any better explanation, please also join the discussion. I think that's a very good question.
I'd like to add to your point that deep learning, even though it's a subset of machine learning and has really taken over almost the complete hype everywhere, but there are use cases. Am I audible?
Yes.
Yeah.
Yeah. So even in the business landscape and the most industry-ready scenarios, they're using machine learning. And otherwise, even on Kaggle, you might see deep learning approaches being really good or being used widely. In general, machine learning is what is being used right now.
Yeah,
Right.
I mean, can you hear me as well? I'm not sure about that.
Yeah.
Yes.
I can hear you.
Okay, cool. So as I understand it, basically, I mean, machine learning is just many more methods, like also lending more to statistics as well. And it's really like an old field compared to deep learning. And basically, deep learning really started to pick up with the GPUs and more processing power, where neural nets suddenly became useful. And previously, people had to get by with like support vector machines and naive Bayes classifiers and all these kind of machine learning tools. And there's many different tools, whereas deep learning really is totally focused on the neural nets and their power. And machine learning basically, yeah, as you said, lends itself more to tabular data. Whereas neural nets basically, their kind of appeal is that they can do end-to-end stuff, right? So for the machine learning stuff, you often do feature engineering. You really have to dig into your data and try to make it better and get more meaning into the data. Whereas the deep learning stuff, at least the appeal and their kind of, yeah, the kind of promise is, okay, you plug data in and you get results out because of the raw power. And the machine learning is often much more tuning involved and digging into it, my understanding.
Yeah.
Yeah, and I think Jeffrey's actually talked about that a little bit in one of his lectures in relation to cancer screening, where a model was generated using expertise versus actually learning from images, and the image version outperformed the model that was based on feature engineering and domain expertise. For me, the main difference is that it's probabilistic, or sorry, it's deterministic, the machine learning, whereas deep learning, the results are not always reproducible, which adds to the difficulty in explaining results. But with machine learning, there seems to be a lot more trust, I think, in industry. If you get a good model that works well and it's machine learning based, it's reproducible and you can explain the results.
True, and I think that's also like one big thing why like random forests and all these tools are still applied in Kaggle and in industry, because you can actually explain what they're doing, right? You can actually try to follow through what's happening, while most of the other complex ones are kind of black boxes. And people want, like, if it's critical issues, they really want to know why a decision was made, and therefore it's still pretty relevant and yeah, quite useful.
Yeah.
Yeah. So yeah, for sure, the deep learning is now very hot and very very popular in especially like the image recognition or the NLPs, or like the that's where it's used actually the most. Although more and more people also use deep learning neural nets on the tabular data, structured data, because the reasons that Jeremy quotes is that you don't have to spend that much time on feature engineering, so your workflow is like shorter. You spend less time on basically preparing your data. You can just feed, and the more data you have, the better actually. That's also one of the concepts Jeremy talks about. So yeah, but that's, so actually he teaches those techniques in this course as well. So the last 4 lessons, they talk about also neural networks. So yeah, so as Jeremy says, that's between random forests and neural nets, you can pretty much tackle a lot of challenges. Yeah.
I need to add one point. Deep learning or machine learning. Okay, I mean to say random forest or any deep learning technique. Which one to choose? It depends on the volume of the data available. Correct? Am I right? Am I right?
Yeah, that's a good point, I guess. Actually, when we're discussing deep learning and machine learning, right, one distinction is also the amount of data that you're dealing with, isn't it?
Yeah, so
If I have a say 5,000 rows or 10,000 rows, okay, so my gut feeling is I will go with machine learning, say like random forest, all this. If I have huge amount of data, deep learning makes sense, right?
Yeah, for sure. For deep learning, you need a lot of data if you don't do transfer learning. Like in the beginning of the deep learning one, right? Jeremy starts off with this dogs and cats thing, at least it used to in version 1, not sure about version 2. And then you can get by with a couple of hundred images because basically your model is already pre-trained. So if you do transfer learning, it's probably not as clear-cut anymore. But I would say in general, like for deep learning to be really efficient and effective, you need a lot of data, and that's a big issue.
So my question is, if I have less data and if I have to do a deep learning, so say, so what I can do? If I increasing the number of epochs, number of cycles will help me, or so what can I do in that case?
so your question is if you have a lot of data, right?
If I have only 10,000 rows, okay.
So you mean to say that you have less data. So when you're having less data, how would you use deep learning? So one point I would like to make is, I think last week or the week before that, Andrew Ng released a tweet, right? In that he mentioned the next, frontier for deep learning would be how to make models that that works well with less amount of data. And in that tweet, there were like a lot of techniques people like discussed. And one main thing is transfer learning. As he mentioned before, like transfer learning is a good way, and other techniques like image augmentation, data augmentation is also one thing.
Yeah, I understand. I understand that images. Okay, we have pre-trained models, so we can do transfer learning. But for a structured data, I have tabular data, and I have to do some deep learning on it. Okay, instead of using random forest.
I think these types of questions are very difficult to answer until you actually try something, because that's been my experience, at least, that you don't really know until you try, because the nature of the data, 10,000 rows, we don't know what's the dimensionality of that data and how much signal is contained within the data. But I've seen models that work well, deep learning models that work just as well as machine learning models that do not have access to huge amounts of data. But then it depends. I mean, if it's image data, then yeah, you probably do need more. But if
So I think the more data, the better. Actually, that's usually the case. But when I was doing this course and I was trying the random forest on Kaggle data set, which was 55 million of rows of data, the more and more data I was adding to the model of random forest, the less accurate results I was getting because my model was overfitting. So yeah, so that's interesting. What I found is that we like to have more and more data, but then we also need to think about overfitting as well. So and that's what's covered in the course as well. But I found this interesting. So I was thinking, yeah, I'm going to add more data and it's going to be better. In fact, it was going worse. Yeah.
Interesting.
Okay, cool. Good discussion. So so indeed, how to run the notebooks. There are many ways. There are many ways actually to run the notebooks. I'm going to mute all of you guys again, and if I can do that quickly.
Has anybody managed to find any problem, not the proper install on setting up Fast.ai on their PC? Because I couldn't. And the issue which I am facing at the moment is a pip. Mine is 10.1, and it complains about installing like pip 18. Has anybody saw that issue? Installing on your PC Fast.ai?
Yeah, I had
just a warning, right? It's not an error, it's just a warning.
Yeah, well, the issue is I'm like, if I ignore it and then I start trying to go and then I start using the notebook, it errors. It says they couldn't find Fast.ai. So it's it gives you, and then what I try to do is I got rid of an environment. I updated my base to 18.1 pip. When I do when I look at the version of the base, it is up to date. But when I go into environment, Fast.ai environment, it's still on the pip 10.0, 10.1, I think. And then it's when I try to update it with this command conda and update -f environment YML, it gives me that pip error.
Did you see that this environment minus CPU that we're using here, not the environment.yml that you would find on the GitHub page when you would do the deep learning class?
I try to use just a conda environment update as well as conda environment update -f environment -cpu.yml, both the commands. Nothing work, it's same error. I was looking at the internet and they say is somehow the pip get cached on your PC. So need to get rid of the pip or a cache. I tried that as well, but that's where I got stuck in installation part. I guess I'm gonna try now Paperspace. I have account with them. I was just curious if anybody else has. I think Michael, you said you had that issue.
Right, so I've tried a couple of times installing on Windows because that's the platform I was trying to install it, and I couldn't make it work. I tried to debug it and tried to make it work. I've tried I have only CPU, so I was installing the CPU only environment, and I could not. It installed that, but when I was running, I was trying to run notebooks, I had kernel issue inside Jupyter Notebook. So basically, I decided not to spend more time on this issue, and I switched to Paperspace and recently to Kaggle. I'm also using Google Cloud Platform, so there's plenty of options that you can run. So yeah, that depends what you want to actually do.
I guess I think I need to move on to a Paperspace or a Kaggle, I guess.
Yeah, you can try Kaggle kernels. I've created the lesson 1 copy, the copy of lesson 1 notebook, which I've posted on presentation. There's a link to that. So the Kaggle kernels is quite a good option, actually. It's free. You only need to create an account with Kaggle, and then you can use the resources, and you can also use GPUs for free as well. So that's not a bad option, but
it is possible to get it working under Windows. I had a whole ton of problems too. I got it working under Windows 10. Eventually, I found the last problem, and it was just searching forums and searching, Fast.ai forums and just general setting up deep learning environments on Windows 10. And they're just from different hints from a bunch of different places, and eventually I got it working, but it took me about a week and a half.
That's right.
That's the thing. That's the thing. I tried my best to install, and then I said, "Oh, better off watching a video." And then I tried after a video, it doesn't work. So sometimes you try your luck. I'm gonna try in the morning or evening. It doesn't work.
Yeah, if you keep hammering at it, eventually you get it. But
all right, I'll try. Thanks for that. Yeah. Thanks.
So I had problems as well on a Mac, and not just for lesson 1, but I also looked at the other lessons, and you need to install stuff by hand. And then also after doing a git pull, it broke some of the stuff too. So what I did afterwards then is that many of the dependencies that are already required in the first cells are not really necessary for the things that we're doing at right now. So every time now there was a reference to Fast.ai, I just used the method directly, copied it into the notebook, and so I saw the code. And now that the notebook is self-contained, which is helpful because I was also using a hosted environment and didn't install the Fast.ai library directly then.
Yeah.
Yeah. And when you clone this the Fast.ai on your PC, I didn't clone. I just downloaded it, and then it created something called Fast.ai dash master. Did you guys do this? Did the same? Like just have one directory and then start using the commands, or?
I did the clone as the instruction said.
Okay. Okay.
It's probably
could get you the same result though. Master just refers to the branch you're pulling, so it's just a naming thing. So the content should still be the same.
Yeah, that's what I thought. Yeah.
In general, I would say it's much more better idea to install Ubuntu and get everything up on there, because eventually you would want to install other libraries as well, and it'll be equally as painful as setting up Fast.ai.
Yeah. Yeah, that's a good point, but also at the same time, yeah, depends how much time you want to put into because we can learn also concepts, and yeah, it's a good point. It's everyone's decision on how to do it. Yeah.
Sorry, go ahead.
I wanted to point out that they've added support for the 0.7 version on pip. I'm not sure if it was there, so you could just pip install 0.7 as well.
Yeah. Yeah.
Yeah, you could pip install previously, so I'm not sure about 0.7, but the previous, like the old version, you could pip install as well, but it was changing so fast that it was a bit pointless because like every day they had an update. And
no, I just checked. You can install the older version as well.
I think they said not to use pip for that. I thought there was somewhere in the instructions saying don't use pip, rather install it. Or do the clone.
They've updated the instructions today, I think so. Because they've added this point there. Yeah.
Okay.
Yeah, I think that the note was because previously it was kind of a breakneck pace how they updated it, and they just occasionally updated the pips.
Right.
And basically it was pointless to pip install because you were always outdated. And you can pip install on Git as well, so you pull from head. And then you just need a Git update to Git pull to bring in the new ones. But yeah.
I would like to say that, all these problems, right? I think solutions will be available by October 20 because the first lesson is on 22nd, right? So till then, this pip install, what Sainam has mentioned, right? That would do. Like yesterday, we were also discussing, we were using Collab to install Fast.ai and using some of the previous notebooks. We had issues of dependencies. So pip install Fast.ai 0.7 works pretty well.
Yeah. Yeah, so that's a good point. So October 22nd, that's where there is a new course. I mean, the new version of the library, which is v.1, that's being deployed in a course, Deep Learning 1, and that's when they're going to start teaching it. However, we're going to still continue, at least that's the thought at the moment, with 0.7 version of the library, because that's the library that this machine learning course is based on. If anyone wants to try on how to port that course into library v.1, that's also would be great. But Christian tried that, I think, a little bit, and that's not so easy, apparently.
Yeah, it was just a bit strapped for time, so I will still try that basically when I have the time to just replicate the current notebook and try to port it to 1.0 code, because like essentially all this stuff should be in the new library. It's just like rearranged different names. But
I faced the exact same issue when I was trying it. It isn't a straight way to replicate results.
You need to read up quite a bit, so it's not.
Yeah,
trivial, I guess. Because there's no web page where it says, okay, previously was that, now it's that. There's no translational page or whatever, right? So you'll have
probably
to.
With the new course, we'll be more familiar with the library, and then we'll be able to look into that.
Yeah, so some of us already registered for that deep learning part 1 course because it's free. It's following the live course from Jeremy. So you can still register if you something that you want to do. Registration is until October 12th. Yeah, and they're going to teach the deep learning part 1 with the new library. So yeah, I think that's a good opportunity to join that course.
Oh, second, when you mean Jeremy is going to teach that course directly? Is that what you're talking?
That's correct. So
that's quite late in the US time.
It's 6:30 Pacific time.
Pacific time.
Two and a half hours. So in Europe, that's the middle of the night, I guess.
Yeah.
And that was discussed in our forums as well. So looks like what they did last time, the course was not open to everyone. It was like based on acceptance, based on some criteria that Jeremy had. But now it's open to everyone. So if you apply before October 12th, you automatically get accepted if you have 1 year of coding experience. That's the only requirement now. You need to check mark that box. Then you're going to get access to live streaming on YouTube of the course, and that's what Jeremy recommends, that you join the live streaming. But like in Europe, it's the middle of the night. So, and what happened last time they did something similar, the videos were available straight away after that streaming. That's what some people say. So you could like catch up like the next morning and then join the online discussion and kind of, yeah, because if you kind of wait, I think you have to wait like a couple of months at least to get that course released for free as this one. So yeah, it's up to everyone else's decision. Yeah, but that's available, and I think it's a good way to introduce yourself to the V1 library. Although it's additional to the machine learning course that we're doing, so you basically need to plan more time to spend on the courses. But yeah, interesting.
Okay. Yeah, I'm gonna ask you one question, Michael. If you go back to this install part, one question was asked on a chat window is, let's say if we go for a Paperspace or Kaggle, is there any facility to add your own data into it? Like, can you upload your own file and then run the Fast.ai model on it?
Right. Thanks, Dinesh, for checking up the chat. Thank you.
Sorry.
So yeah, indeed, yeah, you can upload data to your Paperspace through various different methods. You can do this through you can download the data directly from the internet, like from Kaggle website if it's competition data. Using curl command or using the Kaggle CLI. So there are ways to do it. You can upload that through FTP or you can upload it through SCP. So yeah, there are many different ways.
Many different ways. Okay, thanks for that.
Same with Kaggle. It's a little bit kind of different. The Kaggle is built, but it's more visual. So you click add data and then you just select you upload your data as a data set, and then you add that data set to your Kaggle kernel. So it's a little bit different, but it's also possible. Yeah, and they give you quite a big space for that. You get some 100 gigabytes of things, something like that, for all your data sets. So yeah.
Mm-hmm. And this is a deep learning course which is starting, not the ML.
That's correct. The course that is starting on October 22nd is deep learning.
Deep learning. So what about this version 1.0 library which is coming, which he is releasing? Is he going to do new videos for ML 1.0 or we just start using it?
Right. So I think what the plan from Fast.ai is they want to start with deep learning part 1 now. And then I think Jeremy mentioned they will go with deep learning part 2 like early next year. And I'm just guessing that machine learning will be the next in line. So it will get like maybe Q2 next year. So yeah, so I think that's when the machine learning will be officially ported to V1 of library, but I'm just guessing now.
Yeah, and has he like again? This could be a dumb question to ask, but is the libraries are same for deep learning as well as ML, or he's keeping them separate, or just one set?
It's one library.
Okay. Okay, so it's just the 2 courses. Okay, yeah, got it. So you go through just one trouble once to install, you know, and then you forget about it.
Yeah.
I mean, it's a bit unfortunate that we basically do the course on an outdated library.
Yeah.
But then it's the concepts, you know, and as I said, it should be like 0.7 was right before the 1, and I think they just rearranged the API and everything, so the content should still be applicable. And maybe we figured it out as we go, and we provide the version 1 lessons ourselves, basically. But I have no idea how much work is involved, so I don't want to commit to that. But I'll try on the way.
Yeah.
Yeah.
Thanks for that.
The one interesting thought came into my mind is I think the deep learning or the concept of a Jeremy himself is he goes like top-down approach rather than a bottom-up approach. But for this module, I think for ML, he was saying he's going to go to the basics, then he's going to expand. And I think I heard Sam as well. So anybody else has any opinion how ML, he set up the ML, but not the deep learning?
Well, I think what Jeremy kind of mentioned a couple of times to what I've read and listened was that the machine learning course is still top down, because like in lesson 1 we get to train a random forest regressor already and get some accuracy scores and predictions, but it goes a little bit on a slower pace than the deep learning course. So they go more like slower and also more into detail of the random forests, where in kind of deep learning they go really high level and also really fast. So
okay,
that's my.
The difference is this goes to much more ground basics rather than the deep learning one. The deep learning one assumes you have some knowledge of machine learning.
Yeah, I mean, I did the DL1, the old one, and for me it was a bit hectic and not really. It was a good course, and it's good to do it, but the first learning felt much better to me because you can really focus on what's going on, whereas the other one was kind of running over all these topics and basically expected you to fill in the gaps during the week, which you need a lot of time to actually do. If you just follow the videos and do a little bit on the notebook, deep learning was really tough, I would say, because they really expected you to dig deep yourself.
That's correct. And I think one of the issue in Sam's study group we suffered was lots of people dropped out after 3-4 lessons. I was one of them. So because it was like, I think lots of concepts in one go, and then especially who has started on ML side first time. So hopefully this one wouldn't be that cruel as it was a deep learning.
Pretty good, this one.
Yeah.
All right, you're going to move on to the next slide, Michael.
That's right. If there is no more questions about installs and another, we can move
just
on. Just
conscious of the time, we are 40 past.
Yeah, thank you.
I mean, we can also like if people still struggle, like there's a couple of options how you set up your system, but if people are still having issues, we can just discuss it in Slack and then try to debug what's going on. Yeah. I mean, I'm not expert on Windows, but collectively we'll figure it out.
That's a very good suggestion, and I think everybody, if I look at the chat window, lots of people on Windows are suffering, but then at the same time, I think lots of people who has suffered already got a bit of a remedy as well. So I think this is a good idea. Maybe start throwing questions on the Slack, and then just other people just reply.
Cool. So the next slide I have about Jupyter Notebooks. So this is the tool that it's used throughout the course. It's kind of like an interactive environment to run Python code, and it's quite cool, I have to say. So you can see what's happening with executing the lines of code. It's got some good keyboard shortcuts as well. So like a couple of things to mention, like if you want to see the functions documentation, you just type the question mark in front of the function and execute that line, and then you'll get you the documentation. if you type 2 question marks, you get the source code. If you hit Shift and Tab, it will show you. It shows you the functions, the parameters, like the arguments. If you hit Shift and then Tab, twice Tab, then it shows you that function documentation as well. You can also run the bash commands. So if you type the exclamation mark and then like ls or pwb or any other bash command, it will execute that bash command. And also you can open the terminal from within the Jupyter Notebook. And there's a bunch of the navigation shortcuts that it's worth to learn as well, like the Shift Enter will run your cell. Yeah, you can, by hitting Enter, you go into the edit mode. So you type your code or text. And if you hit Escape button, you enter the command mode. So if you in command mode, pretty much anyone, any keyboard, any key on a keyboard is a command. So there are a couple interesting ones to learn first, but Jeremy recommends to learn 5 per day. Do you have any questions or comments from using the Jupyter?
I want to add one thing. Like often when you're working in the Jupyter Notebook, you sometimes miss out on a library and then you have to kill the server and install it via terminal. Instead, you could just put an exclamation mark and type the pip install command or whatever to, you know, you wouldn't have to kill the server and then again launch the Jupyter Notebook to do it.
That's interesting. I didn't know that. So if you're missing a library, just exclamation and then just install.
Yeah.
Nice.
Oh, that's cool.
That's good. Yeah.
Yeah,
but like I didn't know many, like single question mark, double question mark. None of them I knew. And then I'm new to the notebook, so I'm usually using a menu, but that's a bit tedious. Like I like to have more on a keyboard side. So these are the nice.
Yeah, I mean, one thing to look out for is the state of a notebook, right? It's not like you will run individual cells, and if you jump around and do edits, sometimes the state of your program is different than what you expect, because you might be out of order, right? So sometimes if some stuff is weird, you have to rerun the notebook from top to bottom to be sure that you execute all the stuff in the same state, especially with pandas. If you do in-place edits and stuff like that can be funky. So, but yeah, if you see something really funny, it's always good to restart your kernel and start it from top.
You could press escape and 0 twice to restart the kernel rather than, you know, point of a mouse and clicking twice.
Yeah.
Just another
potentially a stupid question. The bash commands, are they supposed to work under Windows like the ls? Because I had to change one of the things on one of the notebooks in order for it to work to the Windows version.
I think they have dir instead of ls. I'm not sure.
Yeah, I think dir. So it's usually your normal Windows command. So exclamation the window. If you're on the Windows, then you do dir.
Okay.
It's confusing, I know.
Yeah.
And PWD, I think PWD is shared.
Okay.
So it's the same for both.
Right.
I have a question regarding doing, for example, a conda install or pip install from within a cell. So if I have multiple notebooks, then there's some concurrency between the notebooks, I assume, right? How do you guys deal with this?
You'll have to restart the
specific conda environment for every notebook in the first cell, or how do you do this?
In my case, I generally launch it through the Fast.ai environment, and if I install a new library, I just restart all other notebooks.
So you just have one shared environment then, so you don't have conflicting things between different notebooks, correct?
No, there's no conflict, usually in my case.
Okay. Anybody who has lots of experience with it, you also have just one environment for all your notebooks, or do you have separate notebooks for different, there are separate environments for all, on every notebook?
I do have different environments. Like I do have one for Fast.ai or machine learning, whatever. And then I also have a different one for Google Earth Engine, like for remote sensing data and their stuff. It's just, I don't know, it's not really necessary, but I have like 3 or 4 environments in total, but spend most of my time in one environment where most of the machine learning, scikit-learn, all this kind of stuff is installed. But I don't do it like for a project, like in the kernel is for multiple projects which have a similar kind of need for libraries, in my case.
Okay.
Okay, so I have the same like Christian, but now, Sanyam, one question I have is, let's say if you have one environment of all the libraries are there, and would there any be difference in the performance side that all the libraries get loaded, or it's like the libraries which we don't want, like let's say we just want to have like just basic libraries, but we during the course we have installed so many libraries. Would
There's
it
no
make any difference?
performance issue. It's purely for bookkeeping to have your environment sane, right? You want to, like normally, like if you're really picky about it, you have one project and you need a certain version number of your library, then you do it in a virtual environment and kind of freeze everything to this kind of state.
Yeah.
But it's basically to not pollute it with too many different versions, or to keep it kind of tight. But it shouldn't be.
I prefer lesser environments just because Conda sometimes takes up a lot of space. I yesterday cleaned up my environment, and actually I realized 80 gigs were occupied just by Conda itself. So I recommend keeping the number to as less as possible for the number of environments.
Yeah, but the point I originally wanted to make is if you look at the lessons, then Jeremy is introducing, for example, Feather, which seems to be pretty new to PyArrow, and so then you would install it from source, and so every other environment must use the same version then, and you need to install Conda Forge as a channel, which also means every other notebooks needs to use it then. That was the reason I was asking for the isolation, but I think I have my questions answered now for me. Thank you.
Yeah, I'm not so clear now. Your multiple environments, Christian, are you able to have them running simultaneously, like concurrently in different windows?
To be honest, it should be possible. Like you select, like on the top right in your notebook, you have your kernel right next to the circle, and you can select like any kernel you use. So I think it should, like I never really tried, to be honest. If you have multiple tabs, you should be able to select different environments.
I would like warning though, it eats up a lot of RAM in general.
That might be an issue.
Yeah, if you are running various like multiple environments, then you need to access each environment on different ports. I mean, usually it's the notebook runs on 8888.
No, that's only for the Jupyter server. Like the ports are for if you start Jupyter Lab multiple times, then they will direct to a different port. But we're talking basically the tabs inside of one Jupyter Lab session. And then I think you can run multiple environments per, like each tab. But I could check.
Okay.
Michael, should we move on?
I think you're on mute. Michael, can you unmute?
Yeah, Michael, you're muted.
Right, cool. Sorry, I was muted. Thanks for letting me know. Yeah. So lesson 1, we already discussed a couple of topics, but so in lesson 1, I just put a couple of key kind of topics Jeremy talks about. So of course, pandas and NumPy, the libraries that are used in not only in this course, but it's more generic machine learning, deep learning libraries. Pandas is for the data frames, and NumPy is more for, let's say, for arrays of, say, some data. So very important things to kind of learn, at least that's what's needed for the course. And then the type of data is already touched. So this is the structured data and unstructured data. So there's a discussion, what is actually structured data, also called tabular data or columnar data. It's like kind of your data in columns and rows, like if you think Excel thing. And then unstructured data is like images or natural language processes like text or audio or video. So that's kind of the unstructured data. Do you have any questions about that definition of the data? Is that clear? Cool.
Yeah, it's fine.
Yeah, cool. Then the next thing is that, yeah.
Yeah, sorry. So I know this was discussed before. So it usually have a training and a test data sets, but here we have a validation sets. So I think Jeremy used to do, or maybe this is a standard. So I'm not aware. What's the like difference between a validation and test? Is it the same or is it different?
It's different.
How?
Usually, you need for deep learning, you need a validation set for your algorithms. And later on, you need an independent test data set. And the validation set is used in the training process. And basically, it leaks information into it. So you need to separate out a test data set that doesn't inform the model at all, basically. That's not an issue for random forests, like we do them, because, to be honest, I can't really define it, but for sure there's like for the neural nets you have like 3 separate data chunks. And
validation is the proxy to your test data.
Yeah, they should have similar distributions.
Yeah,
exactly. Yeah,
that's actually critical. But for the random forest ones in the beginning, we don't need an actual true test data. We just want to produce a model, but we don't have to verify it like that.
Okay, so but going forward with the ML, are we going to split the data into a 3 parts: training, test, and validation, or just 2?
I can't remember, to be honest.
Okay.
Quite likely, but it's a good thing anyway. It's also for this where you don't really need it. If you have enough data, it's a good thing to have, to be sure.
Yes, and it would be like interesting to know what's the percentage of the test and the validation, and how somebody said it's the proxy for a validation is proxy for a test. What does it do? Like, does it test the model twice on 2 different sets and see the accuracy, or how they are difference? Because I always knew only training and a test. The validation come into just Jeremy's codes, or maybe I heard it recently.
So one point I would like to make is that this validation test split, whatever, the part 3 of deeplearning.ai, the course, in that Andrew NG explains it like pretty well, extensively, like the new ways of splitting your data set for deep learning as well as in machine learning. So like it's a huge topic. Going through that would be like there's a lot of things that we have to kind of talk about, but basically it's that if I just boil it down, let's say you have an application in your like company, you have to you have like image data set. So you have images of let's say cats or dogs, and you want to identify them. And while training a model, you have your train and test, basically, like in your terms I'm mentioning. So basically it's like train and validation. So your test data is like your real-time data. If after like porting it into a mobile, your model, and whatever like the predictions that you get is from your test data. That is what he explains. And yeah, I would really suggest you go through that course 3 of deeplearning.ai. That would clear a lot of doubts.
Okay, thank you.
It's a bit too big to discuss here, I think.
Okay, let's move on.
Yeah, I will post. There's on the Fast.ai page. There is a whole blog how to set up validation set. Yeah.
Yeah, let's put whatever we know on the Slack.
Yeah. Yeah, so there are a couple of points that Jeremy did. This is the Fast.ai library. So the add date part is basically taking the date from the training data and is splitting that into some more. It's like getting more information just from that date. Like, is it start of the year? Is it start of the week? Is it end of the week? Is a weekend? Those kind of information. So that's quite key, and that's what the library does for us. Then other parts of the library is the train cats. Is basically takes your data and gets the categorical variables out of it and converts them into the format that random forest will accept. So like random forest needs numbers. So that's also very, very good function to use. And that's what library makes it easy to use random forests. Also missing values. They are addressed by putting the median instead of missing value, and then also adding a column which also then highlights which data was missing. And the save to failure that we discussed already, it's a very quick way to save a large data sets. And then also ProcDF, it's also Fast.ai library, which together with train cats, so ProcDF would split your trainings, would split your training set into a dependable variable, into the your training data without that variable, and also will convert the pandas library to the pandas data frame into again all numbers, so it's accepted by random forest. Correct me if I'm wrong. This is the way I understood how the train cats and ProcDF. I was a little bit confused how those two work together, but you need them both to get your data set ready for a random forest, basically. And then the discussion we had on the training and validation set. The validation set is actually a very important aspect of training. Mm-hmm. Any questions or comments from the group about lesson 1? Because that was basic.
I want to add that random forest like your data to be in numbers. So there's a lot of feature engineering done just to make sure that it's all in numbers. And Boolean data is okay because it's presented as 0 or 1 if it's true or false.
Yeah. So anytime you have in data like strings, then that needs to be taken care of, and those the Fast.ai library takes care of that. So if you do ProcDF, you'll be fine. Yeah. So actually, why random forests? Because that was kind of my thinking. Why the random forest was chosen as a tool to teach. Because if you go to Kaggle, no one pretty much is using random forest anymore. Everyone's using the the gradient boosting machines, whether it's XGM or the light GBM or any other implementation of gradient boosting machines. But actually random forest, to what we discussed before with Christian, it's easier to explain, I guess, and it's easier to learn as a first tool. And it also requires very few assumptions. So it basically doesn't have almost any assumptions. You can, and also works quite well with overfitting. So there's quite a lot of good things about random forest. And I believe that's the case, that it was chosen by Jeremy to teach that one. Although, as I said, if you look at Kaggle, that's not the tool that wins competitions these days.
Also, I mean, I think it makes for a really good baseline model. Like if you're really digging into something, because it's so easy to get running, it's something like a very good first shot. You know, if you're exploring the data, like he tells that in his lesson as well, right? That he tries to do model exploration, basically, not really doing a full dive into the data yet. He tries to understand what's in there, but not in detail, and then have the model explain the connections and the features. Mm-hmm. I think it was a question from the audience in lesson 1. And I think that's quite neat, because I mean, you're kind of always told, okay, you need some kind of baseline model or assumption, and then you benchmark against that one. And if you have a random forest, apparently you have already quite a good one. And then you might go fancy,
yeah,
to beat it.
And could you transfer something like feature importance to from one model to the other? In the specific case of random forest to XGBoost?
I would assume so, yeah. I mean, if there's content, if there's like actual information in there, it should be, to my understanding, be picked up by other algorithms as well. They might be more efficient, or they might explore deeper. But if a simple algorithm gives you some insight, and it's a true insight, not an artifact, then yeah.
Okay, just in view of time, so what we had more. So this is about overfitting and underfitting. I guess that's a topic for another discussion, maybe for next week. And that's something we also would like to ask you guys. So if anyone wants to present anything, so like, for example, if you would like to present about overfitting, about the validation sets, it doesn't have to be like a very long talk. It can be like 5-minute talk. Maybe you can write like a 1 slide about it. And if you want to talk about it for next week, so then everyone else can learn from that from you, that's great. So you don't have to be expert in that field. Just present your understanding about that. That would be great. So please let us know if you would like to present something. We'll put that in the agenda. That'd be great. So like, for example, the validation sets or underfitting, that would be great for next week for someone. That's not from lesson 1, so we're not going to go through that for now. That's lesson 2 or 3, I think. And this is also not lesson 1, so I'm not going to spend more time. This is what we did basically throughout the course. So this is the questions and answers. Just a quick question, what are you guys doing for the homework? You're doing any Kaggle competitions or have some other interesting data sets you're working on?
I'm gonna try the Google analytics revenue prediction thing, because it's also tabular data.
Yeah.
At least throw it at it and just make use of the date feature engineering and some other stuff and just play around with it. It's quite complicated because it's a complicated time series in itself. So it's probably not ideal for random forest, but just to get used to the library, I'll just play around with it.
Mm-hmm.
I'm gonna follow the Jeremy's suggestion. I'll try to put something on a Kaggle. So somebody mentioned the new, whatever new competition is there, just try to run anything and just upload there just to see, for fun, So that's my plan. Hopefully next time I'll have maybe 1 submission.
Yeah, great. Cool.
Anybody else?
I'm using the NYC pickup data to predict how many caps will be used in for a certain route at a certain time. But so far, there's relatively few data to make the prediction on, and the accuracy or the R-squared score is not as good as with the data set that we are looking at. It's more like 80%.
Okay.
Very interesting. Yeah. Yeah, I think that's key points from Jeremy. Just get some data, to just do some analysis with that. That's how you learn. So yeah. Okay, so the next steps for next week, it's lesson 2. So if you can watch the video, do as much practical stuff with that what you've learned. So like homework, Kaggle, whatever, any data set. And then prepare some questions, discussion points, if you want to prepare some presentation for next week. The last page is about some resources. So I'm going to post that presentation on the Slack, and I think I already did that on the chat. So there's a link to the course page, to the blog post that they launched that course, the wiki thread about lesson 1's got quite some interesting information. Lesson 1 notes, that's actually quite good resource to look into. And I think Sanyam, you did some lesson notes as well, right? I kind of missed that one. I could put that into this later.
No problem, I'll share them in the channel.
Cool, thank you. And then if you did not sign up for those sessions, you can do that with the link at the TWiML and the link with the podcasts. And that's pretty much all from me. We got a bit out of time. So thank you all for participation. Hope to see you next week.
Yeah. Thanks,
all right,
guys.
Thanks very much. Thank you, everybody. See you next week.
Thank you.
Thank you.
Thank
Bye.
you.
Bye.
See you.
Good day, everyone.